All right. Good evening, people. Tonight, I would like to present you something truly stunning. This is the brand new dishwasher from Electrolux, first of its kind. No, not really. This is just a joke. What you see here is the very first robotic vacuum cleaner invented by Electrolux. It's called Trilobite. And actually, if you look over there, does it work? Yes. You see the guy there and a sketch. So that's exactly what you see there, a Trilobite. His name is Michael Tresco. He's a former CEO. And this robot was launched in 2001. And at that time, it was a truly innovative thing. It didn't have an app, because basically, first iPhone started to gain its popularity only in 2008. All right, and today we are going to talk exactly about that. Robotic vacuum cleaner maps evolution, and we will focus especially on gesture challenge. And my name is Dimitri. I'm an engineering manager at fantastic Electrolux division DX Wellbeing. I work here since 2017. I had different roles within software engineering here. My free time goes mostly to my lovely son, also traveling, badminton, but definitely not vacuum cleaning. And now I pass the word to my colleague Razee, without whom this event would not even happen. So she will introduce herself, please.
Hello. Hello, my name is Razee. I've been here at Electrolux only 6 months. I'm working here as a senior mobile engineer. And on my free time, I actually vacuum clean a lot. But yes, apart from that, I love traveling. I'm a foodie, love trying new kind of food, and I train quite a lot. I love training kickboxing. Yeah.
All right, cool. Thank you. All right, a big jump into 2017, skipping all the models in between. This is Pure i9. You also see the real ones here. Pure i9 series, still available for buying, by the way. As you see, the shape is somewhat different from the original one, and of course, it's much, much smarter. And these robots, they got the app. And let's take a quick look at it. So that one was launched in 2017. And as you see, the design is behind the modern standards, but it offered a lot of functionality, which was the focus, especially maps, which take the central part of the app. Like, this is the first thing you see when you start the app, and this is the floor planner. I will talk a bit more about that later. At that time, the map was generated in the cloud and sent to the app as an image. So it was a lot of traffic, and it was very slow. Another jump, 2020. This is the second generation of the app. As you see, the design is way more modern. Besides that, a big change happened. The map is now generated in the app, while the cloud only provides you the data. Saved us a lot of money, to be honest, and also, which is quite rare case, improved user experience. Now let's move to the modern time. Of course, Electrolux got some more robots like Ultimate 700 and the third generation of the app. And let's take a look at that one. Was launched 2022, you can say pretty recently. That's the one currently available in stores. So you heard a lot of map word in my presentation. And you might wonder why. In the very first robot, they were not there at all. But it quickly became obvious that the map functionality is actually crucial for RVCs. Why is that? It allows you to understand how the robot sees your place, where it is, where it cleans, and much more. And of course, this functionality evolved and got improved significantly. So we can exactly take a look at, let's say here, that's the map, just a sample. You see where the robot, when it cleans, it leaves behind itself a track, so you see a trail track, so you see where it cleans. So it's very, very convenient. Of course, you might want to add a cleaning zone like here or a no-go zone. What it is, probably you don't know. So basically, a cleaning zone, it tells to the robot something special about an area of your place. Maybe a spot on your kitchen which you would like to extra clean, right? Maybe it's children's room where you want the robot to be super silent. A no-go zone actually speaks for itself, but just to make sure we understand what it is, basically it's the place where you don't want your robot even to go. For example, maybe it's a floor full of small toys, or maybe it's your favorite ancient floor vase inherited from your grandmother, very fragile. Not the vase, the vase, of course, not the grandmother. Okay. Now, kind of the cornerstone of the whole presentation. This is a use case which will demonstrate you the core problem of what we are trying to solve today. Let's say I have a map, and I want to place a new cleaning zone on it. For my convenience, I'm going to pan it, rotate, scale, whatnot. So let's see my crazy movements in action. Yeah, a bit of panning, crazy rotation. Then I'm moving it. Finally, I found where I want to place a new zone. I choose it, place. Then it changes the size a little bit. And then even the shape. Here comes the big question. How do I know what coordinates to send back to the robot of these 4 points? Because the zone consists of 4 points, right? How do I know what coordinates to send back after I did all this magic with a map? Rotating, moving, panning, whatnot. So simply put, we need to know where we are with our map in order to calculate back the position to the robot coordinate system. And to answer this, we need to dig a little bit deeper into 2D transformations, because these actions are exactly 2D transformations. And the first one is offset. What is it? It's basically when you want to take a point or maybe a set of points and you want to move it by X and Y. Pretty straightforward. This is just an example. We have a point, we have an offset. What do? You simply sum up, right? Now I want to present you something which we specially prepared for tonight. This is like an app which we quickly wrote. This is the sample map. And this, our little friend, red dot, or you see actually half of the dot, it's because it is placed in the origin of the coordinate system of the phone, 0.00. So this dot is basically will be used in our presentation as a centroid. What is it? Simply put, centroid is where you put your finger and then you do the transformation. Or if you need to do like scaling or rotating, it's maybe 2 fingers or even more fingers. But to make sure you understand exactly what I mean, let's say I'm sure you do that maybe on a daily basis when you scale up or down an image. So you use 2 fingers and this known gesture, right? So what centroid is? It's imaginary line between the place where your fingers touches the screen and it's the middle of it. So that's the centroid for this particular case. All right, now you know about the map. Now you know about the centroid and the red dot. And let's see what happens if we apply that logic to that map. Okay, looks like it works. So my fingers were maybe here and here. Then the centroid appeared to be here. And offset, no problems whatsoever. Cool. Then we can move on to the next one, scale. How about scale? What does it do? Basically, you either make everything bigger or smaller, right? How do you do that? In offset, we summed up stuff. Here, we're going to multiply. So in this particular case, to multiply with 1.5. And again, initial point. And again, this is the example. Let's take a look how it works. Well, it scales, right? But something feels not really right. What? What is not right? our centroid of the fingers is here, but the map was growing somewhere from here. And this somewhere is basically the origin of the coordinate system. So that's not what you expect when you use your two fingers. How can we solve it? Well, it means that basically we need to put our centroid of the fingers into the origin of the coordinate system. It means we will deduct everything. Yeah, the math became a bit more complicated. So you shift everything by your centroid, then you scale, and then you put everything back. Let's take a look if it works. Oh yeah, look, beautiful. That's much better. Cool. Let's move to the rotation part. What is rotation? Again, you have a point or maybe a set of points, and you just want to rotate it along some point as well. How do we do that? Yeah, this time the formula is a little bit more complex, but that's not interesting in our presentation. I'm sure if you really want to know how it works, you can search on the internet, you will find the answers. What we're trying to solve here is the movement itself. So yeah, let's see if we apply that simple principle here. What happens? Well, it rotates again, and looks like the problem is exactly like it was before, i.e. the red dot is here, our centroid is here, but the rotation is happening around the origin of the coordinate system. Okay, how do we solve that? I guess we can try the same principle, right? Yeah, exactly. So we shift everything, then we rotate, and then we shift back. Will it work? Yep, it works. Beautiful. Now it's exactly like it is expected. Okay, let's see how it works if we put all the gestures together in one map. Will it work? Scaling, rotating, panning, yeah, works. Now I change my fingers to a different place. Yeah, works beautifully. That's exactly what we want. Okay, to sum up. What do we need to do this kind of transformation? Offset, scale, rotation, and what's important, centroids, right? And you might wonder, why do we even talk about that? Why do we need all that stuff? We have Swift UI. You get these gestures just out of the box. Well, yes, but there is always a but, right? Actually, Swift UI doesn't give you enough information to do the trick. It will give you all this panning, scaling, rotating, but it will not give you centroid. It means after you do your transformations, you will not know where the map is. So you cannot connect back if you want to place a zone. And here, I pass the word to my colleague Razee, who will show you the solution in the code. Please.
Thank you, Dimitri. So, as Dimitri mentioned, we had two challenges while developing this feature. One of the challenges was that we needed to know the centroid point, and the other one is we really need to know how to handle multiple gestures simultaneously. So our project is mainly implemented using Swift UI, but when we started implementing this project, Swift UI was relatively new, and it had some limitations in terms of solving this kind of complex gesturing. And it somehow still has their problems. We didn't figure out how to solve it yet. Maybe we can dig in more into it once this presentation is over. So, how did we solve this problem? We have the Swift UI layer. The Swift UI layer is the visual layer. It is what the user sees. In our case, the flow map is a Swift UI layer. It is responsible for displaying the map and also showing the visual part after the user has interacted with it. Then we have the UI kit. So the UI kit is a layer that is responsible for handling the gestures. It tracks where your fingers are on the screen, so we know where the centroid point is. It also helps us to handle multiple gestures simultaneously, such as zooming, moving, and rotating. And then these data is sent back to the Swift UI layer. But the question is, how do we do that? So if you have worked on projects or features where you have integrated UI kit and Swift UI together, then you have probably heard about UI view representable. Sorry. UI view representable. The UI view representable here is sort of like acting like a bridge, integrates these two technologies together, ensuring that we can have this kind of gesture handling in a Swift UI view. But this is not enough, because we want to make sure that we can process the data back to something that handles all this processing. Therefore, what we did is we implemented a view modifier and attached it to a view. And this is reusable, so we can basically add this view modifier to any kind of Swift UI view, and this feature will be still, we can apply it to different kind of features, basically. We have something called transform gestures. What it does is it decides what the data should be doing. So the view modifier here is attached to the Swift UI layer and is sent to the transform gestures to be further processed. It decides what to do when there's been a change in these raw data. And then it sends to the view model. The view model here, it handles the business logic. It keeps track of the map's current state, how much it should scale, how much it should rotate, and how much it should move. When a gesture happens, the view model is informed. For example, the user moves, it says the view model is informed like, hey, move 1.5 points. And then it processes it, because as Dimitri mentioned, we have some mathematical calculations going on, and everything is done internally. That is why we have a mathematical processor. This handles all the kind of calculations. Then we have the gesture processor. The gesture processor is basically telling us what is allowed to do or what is not. So it's sort of like a traffic lighter. Says, yes, you can scale this much, and not, because sometimes you want to make sure that it doesn't move off the screen. And the view model itself is handling all the business logic and state and reflecting it back to the Swift UI. So this is overall the solution that we have currently in our app, and it works very smooth and handles all the different kind of gestures simultaneously. I'm going to show you a quick demonstration on how this works in our real app. You can see it moves. Then you move in, you rotate. Everything is done simultaneously. It's quite smooth. Yeah. Yes, it's a lot of code. We don't need to go into detail, but I just want to show you very quickly on how this has been implemented. So this is the UI kit layer. It's responsible for detecting the gestures. Here in this code, we only show you the pan, which is moving. We have this function. This allows us to handle multiple gestures simultaneously just by setting it by true. And whenever there's been a change in the state of the pan gesture recognizer, then we add this center change, for example, or the offset change, and making sure it gets updated. Once there's been a change on these data, we send it to the transform gesture changed, and this is reflecting back to the Swift UI. This is the custom view modifier. This is the one that is attached to the Swift UI layer, and also it is integrated with the UI kit. So this is the gesture view, it's a UI view representable, and we set as an overlay. It's just handling the gesture. You don't see anything, it's just on top of it. And we have some bindings. With the bindings, we can make sure when the data is changed on the UI kit layer, the data is reflected back to this view modifier and updating this to the Swift UI layer through this onChange function. This is the Swift UI layer. This is not a working code, as you probably can see, but this is where we attach a custom view modifier. We take the instance of transform gestures that is deciding what to do when the data has been changed, And here, in this use case, what we do is it sends to the view model and in order to be processed further. And this is the UI, the view, where the map is being seen. And what we can see here is that once the data has been updated, we get the data from the view model to be updated. So all the rotation, scaling, and offset is done, and it has to be written. We have to have this in order to work it. Yes, we said it. We do everything locally. All the mathematical calculation is done. We don't use any kind of third-party libraries. These are just some set of functions that we have in place. This is our presentations. Thank you, and this is an open place for any kind of questions.
We have this special. We have this special box. You need to catch it, and then you can talk here. Okay? I think you were the first one. Are you ready?
Yeah. Do I get
Oh.
Do I get a robot?
Yes.
Do you get the robot?
I can get that robot. Oh, that's amazing. Right. If you go back to the code, I understand that Swift can't handle multiple gesture recognizer things, therefore you're using pan gesture. But are you able to use like a binding and a state and those kind of things? Because your centroid change all the time. And I see that you're still using like this set private thing. And with the Swift UI, you should be able to take advantage of like automatic updates.
Yes. So this is a UI kit layer. Can you hear me? Yeah. So this is the UI kit layer. So this is the code we have somehow in our current app, and this is how it was implemented. Yes, there are probably different ways to do it with a modern Swift UI, but this is how we did it, and we're using a UI view representable to bind the data back to the Swift UI layer.
Yeah.
I'm not sure if I answered your question.
And I think you said you had multiple. That's just the pan version.
This is just one version. Yes,
because
exactly.
You see, should recognize simultaneously returns true. So you can have multiple.
Yeah, we have. This is just one example. We have a different kind of gestures.
Yeah, I meant like if they can't use Swift UI because Swift UI can't handle, if I understand it correctly, it can't handle multiple gesture recognizer.
You can.
Falling back. Oh yeah. I'll come up with the next one, please. If I take that presumption now, and then you're falling back to the UI kit because the gesture recognizer, it is pinging in the star. It is really, really annoying because you want to use it. It's like great with the screens. It has legacies, but now it's like when everything is upgrading with 2D and 3D and like all those things. You just have to have different versions and fallbacks. So I totally understand that you have to use UI kit, and all this code is like, oh, what? So I was just wondering because I used to write this code but you can still take some advantage of this state change. I was thinking.
Yeah.
Maybe in some other code you're using these bindings and a stay.
There are many different ways to do it. This is just an example of example code.
Yeah.
But to answer your first question, as you mentioned as well, this is just one of the examples of the gestures. We have multiple ones.
Yeah. Got it.
And if you have the luxury of having latest iOS only, you can actually do it in Swift UI.
Yes.
You probably don't have that.
Exactly.
No robots. Your turn.
Yeah, next one. Your mic is off, I think.
Off.
So I was just wondering, was the missing pan gesture recognizer the only reason why you chose to dip down into UI kit? Because otherwise you can come really far with simultaneous drag gesture recognizers in Swift UI.
Yeah, I think we checked that Swift UI even today does not give you centroid information. So if you need to recalculate back, like if you need to know where you are after doing movements, SwiftUI will not help you. Simultaneously, yes, you can do that with SwiftUI, absolutely. But how do you know where you are after doing those gestures?
But if you have 2 touch points, 2 separate drag gesture recognizers, like 2 figures, you can calculate the center in the software.
Well, maybe we don't know something. I would say we started this 2021, and SwiftUI at that time was quite young. So at that time, for sure, that was not possible. Maybe today, if we dig deeper, maybe. What we checked quickly, still Centroid part is missing there.
Yeah, I experimented with an open source package that I have that is called Gesture Button that lets you do like single tap, double tap, long press, repeat press, drag information with one gesture recognizer basically.
Mm-hmm.
Yeah.
But it would be really interesting to just also figure out the panning thing because I don't want to mix a lot of gestures, so I was just curious to see if you could do it with just
Yeah.
Oh, do I understand it right? Like, the drag, yeah. I mean, because tap is a really interesting thing. The drag, you can have Centroid in the SwiftUI. That's not a problem.
I mean, if you have 2 drag gesture recognizers, you get the position of every drag, like every time you drag gesture changes, you get the coordinate.
The dragging is not a problem, I would say.
Okay, one UX question.
Hello. So one more question,
Yes.
and no back and forward this
Yes.
much. We need to be respectful to the presenters. They did a great job.
Yeah, you did. Thank you so much for the presentation, by the way. So this is more of a UX question. In your app, I haven't tried it. Do you support, double tap and then move up and down to zoom in and out?
No, not really.
Okay, can you add that? I'm sure.
Yeah. When it comes to UX, we have designers. We rely kind of on them. You are absolutely welcome to give feedback about that you feel this is a convenient way to do stuff. We actually, I would say we listen to everything we get through Apple platform, If we get enough sort of weight on some feature, which is requested, then I think at some point of time we will implement that.
Thank you. Who wants this?
Let's do coffee break.
Yeah, we're gonna take a break. The presenters are gonna be here. They're not gonna run away. People are nice, trust me. And you can talk to them later on. Yeah, you can throw it if you want to. You can talk to them. You can talk to them on the break and in the mingle session. That's why we have them. Go ask questions about Electrolux. Yeah. Thank you, everyone. Be back in 15 minutes.